Folks, welcome to Statistics. What's up, folks? Welcome to the next lecture of statistics. Today we're going to be taking a look at how to summarize a distribution. Over the last few lectures, you've learned some key terms and concepts. For example, you've learned to describe asymmetrical data using terms such as left skewed or right skewed. You've also learned that data can have one mode, in which case it's called unimodal, or two modes, in which case it's called bimodal. You've also learned that data can be described as symmetric or asymmetric. Now we're going to be using all of the knowledge we've learned over the past few lectures to go ahead, try an example, and summarize a distribution. So, today's problem is going to be about summarizing the fuel efficiency of a 2012 Toyota Corolla car. Let's go ahead and check it out. Alright folks, so here's the problem we've got today. How would you describe the fuel efficiency of a 2012 Toyota Corolla? Well, first and foremost, what we need is the histogram. Let's go ahead and check it out. Alright folks, so we've just drawn our histogram, we've just drawn our conclusions about the data, but before we go any further, this histogram is missing two key components. Number one, labeling the axes, and number two, a title on the histogram. So let me give you the title. Okay, this right over here is gonna be my miles per gallon. Okay, and this is, for example, the number of times that I refueled my car, or who knows. Okay, so this title for the graph is gonna be the fuel efficiency of a Toyota Corolla, fuel efficiency of 2012 Toyota Corolla. Okay, now how do we summarize this histogram? Well, first and foremost, you might notice that we have only one peak. We have only one peak, ladies and gentlemen, and that right there is the key signature of a unimodal distribution. Okay, one peak, unimodal. Okay, what else can we see? Well, it is approximately symmetrical. Okay, even though this isn't pitch perfect, left skewed or right skewed, we can approximately say this is symmetrical. If you were to fold it in half, it would look about the same on both sides. Okay, so we made so far two conclusions, that this is number one, unimodal, and number two, symmetrical. Can we say anything else? Well, yes, we can. Number one, let's look at the standard deviation, shall we? The standard deviation is 2.45. But what does that mean? Well, think about what you're actually doing. You're filling up the tank of your car every time your car runs out of gas. So this standard deviation tells me that from tank full to tank full, the miles per gallon, the fuel efficiency of my car will be different from the average by 2.45 miles per gallon. Let me say that again, okay, because this is how you interpret the standard deviation, and it's where many students mess up. So this is how we can interpret the standard deviation right here. We say that this standard deviation of 2.45 represents the average deviation from the mean of 22.4 miles per gallon. So that means every time you fill your tank, the average amount you'll differ from the mean will be 2.45 mpg. Okay, so that's our interpretation of the standard deviation. So we've got our unimodal, we've got our symmetrical, we've interpreted our standard deviation, but have you noticed there's an outlier right here? There's an outlier here, and we should interpret that. The outlier is at about 15 miles per gallon, but looks like the outlier doesn't really pull the mean to the left. Okay, and how do we know that? Well, we see that the mean and the median are approximately the same. And when the mean and the median are very close to each other, that's the sign of a symmetrical distribution. So it seems like this outlier doesn't mess up the mean too much. Okay, so we've concluded that this distribution is unimodal, it's symmetrical, there's an outlier at 15 miles per gallon, the mean is about equal to the median, which tells us it's symmetrical, and finally we've interpreted the standard deviation. Okay, ladies and gentlemen, we've done our job in interpreting this amazing histogram. Okay, now, before we leave it at that, here are some tips and tricks when it comes to summarizing quantitative data. But first, let me go ahead and erase this whiteboard. Okay, so we're now ready to take a look at the tips and tricks when it comes to summarizing quantitative data. So here are some tips and tricks, okay? And by the way, these are not tips at all, because if you forget these, you're going to fail your exam. So try to keep this in mind the next time you summarize quantitative data. First and foremost, and this is where a lot of students mess up, is when do you use a histogram, when do you use a bar chart? So it's important we make that distinction. When do you use a bar chart versus when do you use a histogram? So when do you use which one? Okay, well, first and foremost, the most important distinction is that bar charts are for qualitative, histograms are for quantitative. Make that note right now. So bar charts are for qualitative categorical data. So let's keep note of that, qualitative categorical data. Whereas histograms, to even use a histogram for a data set, your data set needs to apply and master which condition? The quantitative data condition. Your data set must pass the quantitative data condition so that you can apply a histogram to it. Okay, so let's summarize our first point. You got qualitative or categorical data, use a bar chart. You've got quantitative data, use a histogram. Easy, done. What's next? Well, a bar chart, what does the bar represent? Well, the bars in a bar chart represents the counts of a categorical variable. Okay, represents the number of cases or the number of counts of a categorical variable. Okay, case in point, let's say you asked registered voters, did you vote for Donald Trump in 2020? Well, that's a yes or no answer. It's a categorical variable. So if you look at the bar chart, your variable can be yes or no, and each bar chart will represent the number of people who responded yes or the number of people who responded no. Okay, so that right there represents the number of cases of a categorical variable. That's what the bars in a bar chart represent. Okay, now let's look at a histogram. If we look to a histogram, what do we notice? Well, we notice that we got pretty much the same thing, except here we know the number of cases of a quantitative variable. And the other difference in a histogram is that it often uses intervals, in intervals. Okay, so when you're using a histogram, you have equally sized bins, equally sized intervals, and in each of those bins, each of those intervals, some number of cases of a quantitative variable falls in. Okay, so those are the two important points to make when it comes to using bar charts or histograms. Okay, so make sure you keep these in mind. Now let's see if you've actually learned that, because we're going to apply what we just learned to go ahead and summarize a piece of data. So I'm going to ask you folks which histogram is correct. So I'm going to give you two histograms. Alright, so here's our two histograms. We've got histogram A, let's call this histogram A, and let's call this histogram B. Which is the right histogram if I want to summarize the number of eagles I saw over the last few weeks? Or rather, the distribution of the number of eagles I saw. Well, can you notice which one is the right histogram? Well, it's this one, right? It's A. Think about it. When you're summarizing quantitative data, you want to have what you're summarizing on the x-axis. So right here, we're summarizing the number of eagles we saw. And on the y-axis, you want to make sure you have who you're counting against. And that who doesn't have to be a person. It could be a time period. It could be a week. It could be some kind of a unit. And here that unit is number of weeks. Here, this kid messed it up. He switched it up. He's got who we're measuring on the x-axis and what we're measuring on the y-axis. Totally different. He's in a parallel universe. Who knows if God can save him? And as a matter of fact, nobody can save this student because he just failed his midterm exam. This student, however, has succeeded the midterm exam by all counts because he's put what he's measuring on the horizontal axis, on the x-axis, and what we're measuring is the number of equals, and he's put who we're measuring, which is the number of weeks, on the y-axis. So keep that in mind. When it comes to quantitative data, check number one, that your data meets the quantitative data condition. If it does, you can use a histogram. But if you use a histogram, put what you're measuring on the x, put who you're measuring on the y. Keep that in mind. All right. And next up, what should you remember? Well, make sure you sort your data before you compute the median or you compute percentiles or quartiles or all that good stuff. And the final point I want to make is something critical. Multiple modes. All right. So this is a subtle point, but when you go into higher level statistics or you actually collect data, you might notice that your distribution is bimodal or trimodal. If that happens or when that happens, maybe you're grouping your data incorrectly. If you actually slice up your data in two different groups and analyze them separately, and you have a unimodal distribution for each, maybe that's a better path to take. Just something to consider. All right, folks, that's it for this lecture on statistics. We'll check you out in the next lecture. Thank you.
Embedded plus MKO plus scaffolding equal learning. We believe anyone can learn anything. That's why our motto is memorization is a crime. And that's why we partnered with Brilliant.
Brilliant transforms math and science into hands-on activities so that you too can understand everything from first grade math to E equals MC squared. Barry Science Lab and Brilliant is your MKO and will give you the scaffolding to expand your ZPD until you become the next Sir Isaac Newton or Albert Einstein.
Visit brilliant.org/Barry Science Lab today. And the first 50 of you to use that link will get a 20% discount on the Brilliant annual subscription.
Don't forget that you too can become the next Einstein. So let's fall in love with math and science.